Good evening, student. Today my topic is Gauss law. Already I have discussed about electric flux. Now I will discuss about Gauss law. So Gauss law tells us the total flux linked to a surface is equal to 1 by epsilon naught times total charge enclosed to that surface. That means if you represent a point charge, due to point charge, electric field lines or electric field intensity goes radially outward. If we assume a Gaussian surface like it's a spherical surface, so that electric field intensity in every point on that surface remains same or constant, because the radius of that sphere remains constant in all direction. Clear? So according to that definition, flux is equal to the surface integral of electric field intensity dot ds vector, which is also equal to q divided by epsilon naught. Hence, proof. We know from electric flux phi equal to surface integral of E vector dot ds vector. Here electric field and area vector both are vector quantity, so the dot product is given by the surface integral of E vector dot ds vector, because here if you assume a small region on that surface, so electric field intensity and the region whose orientation or direction along the direction of electric field, so both are in same direction, so the angle between them is 0 degree. In magnitude form, it can be represented as the surface integral of E ds cos 0 degree. Okay? We know electric field intensity in all direction remains constant, so E taken in outside the surface integral of ds. That means the angle between E and ds is 0, so cos 0 is 1, so ds is here. So the integration of ds, that is the, here we write there is a small region is here, there is a small region is here, there is a small region here, so in every direction of the sphere the direction of area vector and the electric field intensity are along same direction, so the angle between them is 0 degree. So total flux generated due to spherical surface is given by E into S, because integration of ds is S. So integration means addition of all the small surfaces. So E into S. So phi equal to what? Es. So here we write E into the surface area of the sphere can be represented as a 4 pi r square. Surface area of sphere 4 pi r square. So phi can be represented as E into 4 pi r square. we know electric field intensity can be represented as 1 by 4 pi epsilon 0 q by r square into 4 pi r square is 0. So phi equal to, in right side 4 pi cancel out, r square cancel out, so phi equal to q by epsilon naught. So that is the formula of Gauss law. So already I have written as phi equal to surface integral of E vector dot ds vector equal to phi by epsilon 0. Clear? Second thing is Coulomb's law from Gauss law. We consider a point charge due to point charge electric field intensity moves radially outward because the point charge behaves as a positive charge. If we assume a Gaussian surface like as spherical, so that electric field intensity remains constant on that surface. We know Gauss law. Phi equal to surface integral of E vector dot ds vector. In that region, if you consider a small region, the electric field intensity E vector and the area vector both are in same direction. So the dot product is represented as in the form of magnitude. So surface integral of E ds cos 0 degree. That means surface integral of E ds, because cos 0 is 1. We know the electric field remains constant in every direction on that surface. So E taken in outside, the surface integral of ds. So phi can be represented as E equal to the surface integral ds can be represented S, because the small region becomes adding, so it represents as a total surface by using integration. So it can be represented as ES. So surface area of that sphere can represent as E into 4 pi r square, because surface area of the sphere is 4 pi r square. So phi can be represented E into 4 pi r square. We know electric flux phi can be represented Q by epsilon naught. So comparing both the equation 1 and 2, so Q by epsilon naught equal to E into 4 pi r square. That implies E equal to 1 by 4 pi epsilon naught Q by r square. As we know that electric field intensity equal to force per test charge. That implies force equal to electric field into test charge. So here you write electric field intensity can be represented 1 by 4 pi epsilon 0 q by r square into q naught. That implies, so force equal to its magnitude equal to 1 by 4 pi epsilon 0 q naught by r square. Already I have know that the Coulomb's force is given by 1 by 4 pi epsilon 0 q naught by r square. That is same thing which is given from Gauss law. So that can be represented as a Coulomb's law from Gauss law. Clear? Some important point which is given to you. If there are three surfaces like a spherical, cuboidal and irregular surface, and which represent a charge, that charge is placed inside it, and that charge whose magnitude remains same in all these things that happen, the total flux linked by all these things remains same. So phi 1 equal to phi 2 equal to phi 3. Similarly, if you consider there are number of charges which are present inside it and few amount of charges present outside it, so we could not consider outside the region, only we have to consider inside the region. So that the total charges inside the region, so the assuming fluxes, that flux can be represented as phi equal to phi 1 plus phi 2 minus phi 3 minus phi 4. Clear? Similarly, if you consider a cube and the charge which is placed inside it, therefore net flux which is goes radially outwards, that flux can be represented as phi equal to q by epsilon naught. And also the faces are symmetrical to each other, therefore the flux linked to each face is given by phi equal to 1 by n times of q by epsilon naught. That means phi equal to phi divided by n, that means phi net equal to phi means total flux linked to that surface divided by n, which is given to you. Clear? Thank you.